Our first question I want to discuss with you, in figure 2.4, is urban climates. Now, when we look at urban climates, very important, there's two things that we need to differentiate between the two of them. That we need to draw up. We need to look at urban, and we need to look at rural areas. Okay. Now, how do we define urban? Urban areas is where secondary and tertiary activities takes place. Rural areas mainly focus on primary activities. Okay. But what's important over here, if you look at this urban climates, they've highlighted this on a graph. Now, please pay attention to your X and your Y axis. Obviously, they mentioned Fahrenheit over here. We don't use Fahrenheit in South Africa. We prefer to use the measurement of degrees Celsius. Now, immediately, if you just look at this graph that's been represented over here, we can see that the higher temperatures is being experienced over the urban areas. Because as you can see, that's a CBD right over there in the middle. How do I know it's a CBD? First of all, tallest buildings, and highest density. Okay. Now, as you can see, this is almost like an urban profile that's been given to you. You can see the commercial properties. When we talk about commercial properties, we look at shopping centers, we look at light industries, for example, and there's a transition zone in between them as well. So now, for instance, when we look at our back, if we look at our graph, you can see that our rural areas are situated on the outskirts of our urban areas. As you can see, the suburban residential areas, when we talk about suburban residential areas, we talk about the low, middle, and high-income residential areas. Now, the rural areas is usually on the outskirts, okay? But what you need to pay attention to is, it's a graph that's been provided for us, okay? As you can see that the temperature increases towards the urban areas. It becomes warmer and hotter, okay? Now, if you have a look at this graph over here, you can see the temperature increases towards the urban areas. Okay, temperature are decreasing towards the rural areas. Now, before we go and look at the questions, why is that? Okay, first of all, even in our diagram, on our graph, we can see that the rural areas is covered with vegetation. Okay, remember, vegetation, trees, plants have a cooling effect. Okay, now if we look at our urban areas, it's usually, we refer to the term that we use, the terminology that we use, it's artificial. Okay, what does artificial mean? It's fake, it's man-made. I mean, if you look at an urban area, let's just assume we look at Joburg CBD. Okay, Joburg Central Business District. It's massive buildings covered with concrete, glass, tar road surfaces. Okay, what does these surfaces do? They either absorb the heat or they reflect it. Okay, so it creates a much warmer conditions. We refer to it as an urban heat island as well. Okay, now if we compare it to the rural areas, covered with vegetation, open water surfaces, you know, it has a cooling effect on the surrounding environment. Now, I even haven't discussed the influence of human activity. Now, what do? In rural areas, we experience less people. Okay, much less people, much less activity. Now, we only focus on primary activities, okay? But in urban areas, we focus on secondary, tertiary activities, even quaternary activities. When we look at secondary activities, we think of manufacturing, making, we burning, fossil fuels, cars, air conditioning. Okay, it all adds to the heating factor of that CBD. Very important. Now, coming back to our figure 2.4, as you can see, that the rural area is covered with vegetation. It's much more vegetation in the rural area than in the CBD, the urban area. Okay, so we can see that the vegetation is actually decreasing towards the CBD. Now, this is late afternoon temperature. Pay attention to our x-axis as well, but we're going to concentrate on the degrees Celsius situated over here. Now, if you look at our first question, 2.4.1, state the highest temperature reading recorded in the CBD. Now, that's very simple. It's just by reading the information on our graph. Now, if that's 30 degrees and that's 31 degrees, so that means that's going to be 30,5 degrees. 31, 32, that's going to be 31,5, 32,5. So if you look at this graph, it shows just a little bit above 33 degrees. So I'm going to mention 33.5 degrees Celsius. So the correct answer for 2.4.1 will be 33,5 degrees Celsius. Okay, how did I manage to get the answer? The actual heat represented in this line graph, and you just read the information from your x-axis on your right-hand side. Now, if you look at 2.4.2, account for the lower temperatures recorded in the rural areas depicted in figure 2.4. Now, I've already mentioned the first thing that's standing out is the trees. Let me just clean our graph a bit. Okay, give me some working space. Okay, so I'm just going to number it, right, and then I will write it down. Okay, so I've mentioned to you definitely the vegetation have a cooling effect on the rural areas. Okay, so I want to write it down there, the answers. First of all, 2.4.2, account for the lower temperatures. So what we basically need to discuss, and I'm going to mention quite a few, you can mention any of them. Why is the rural areas cooler than the CBD or urban areas? First of all, more vegetation. Let's just say natural vegetation. Okay, first reason why. The second one that we can mention, now keep in mind, when we look at our commercial properties like the CBD. Now imagine, like for instance, we are supposed to experience high-felt thunderstorms this afternoon here in Johannesburg, but we haven't. But let's assume it rains for a couple of hours. What happens with that rainwater? Okay, it's usually surface runoff. Why? The water can't infiltrate. Why can't the water infiltrate? Because it's an artificial surface. That water goes lost into our sewage and our drainage. Okay, constructed drainage in our CBDs. What happens with the water when it rains in the rural areas? Because it's covered with vegetation, with soil, what happens? The water infiltrates. Okay. Once again, have a much cooler effect on the surrounding environment. So what can we add? We can write the following. Okay. Rainwater is able to evaporate and cool the area down. Okay, once again, I want you to think of a scenario. It rains in the rural areas, in the farming communities, okay? What happens? Right, the water infiltrates, but also there's a chance for evaporation to take place, having a cooling effect, okay? What happens in Joburg CBD when it rains? All that water getting washed away because the water can't infiltrate and goes into our sewage systems and drainage systems, okay? No cooling effect whatsoever, okay? Another reason that we can mention, we can say the rainwater can infiltrate, like I just mentioned. can be absorbed by the plants. Okay, and very importantly, Kathy was on just before. You know, when we look at life sciences, we talk about evapotranspiration. Okay, it's when the plants releases water vapor. Why? Because of moisture that they received. So we can mention releasing evapotranspiration. Okay, now if we go back to our diagram, first of all, think of the activities that's taking place. So I've mentioned the urban areas, the CBDs. There's so much more activities taking place. Okay. Now, when we think of it activities, think of it, we're adding more heat. A simple example, right? If you think of an air conditioner, yes, it makes it nice and cool during the day. But if you look at the extraction of the air conditioner, it's warm air that usually comes out of it. Same with a car. Now, do yourself a favor, right? Place your hand behind the exhaust outlet. You will find it's warm, polluted air coming from the combustion of the engine. Okay. This all of that adds to the heating factor of the urban areas, contributing to higher temperatures. Okay, we have less activities taking place in rural areas. Mainly we're focusing on farming activities, fishing, mining, etc. Okay, so the human activity by polluting is also less in rural areas. So let's write that down as well. So we mention, okay, less pollution being generated in rural communities. Okay, and lastly, but I've mentioned that density is much lower. What does density means? It's the amount of people living there. Okay, it's much less density. People live far from each other. I mean, if you look at population density from Johannesburg to Magaliesburg, there's so many more people living per square kilometer in Johannesburg than Magaliesburg. Now, all of these people contribute to that factor. We're talking about heating, we're talking about cooling, okay? And we're talking about deforestation taking place because of the people tend to move there, creating more artificial surfaces. Very important. So the density is lower, we can mention that, and we can also say the building heights is lower. Okay, so as you can see, that's the reason our rural areas experience lower temperatures. Now, our next question, 2.4.3, describe how artificial surfaces in the CBD contribute to the heat island. Now, I've mentioned it. What does artificial mean? It means it's fake. Okay, we have created it. It's man-made. Now, how does these surfaces create warmer temperatures? It's very simple. Okay, I always use the best example at school, right? During break time. Okay, let's assume your break is at 12 o'clock in the afternoon on a hot summer's day. Okay, if you go and stand on the rugby field, right, that's covered with vegetation, or you're going to stand between the classroom on the concrete, which area is going to be experiencing the warmer conditions? Okay, the concrete surface or the rugby field? Okay, yes, keep in mind, let's just assume there's no shadows of trees or whatsoever, shade close by. So you're thinking of the concrete surfaces between the classrooms and the rugby field. Which one is going to have the coolest effect? Definitely the rugby field, because it's covered with vegetation. Okay, what does that concrete do? It absorbs the heat, creating warmer conditions. Now, that's what I mean with the artificial surfaces. There's so many of them. And so many of them are extremely dark, right? For instance, tar road surfaces, right? It absorbs so much heat. So that's the first point we can make for 2.4.3. How do they contribute to the heat island? Okay, now 2.4.3. Okay, the concrete and metals retain more heat. Okay, then we can also mention that many of the buildings, I mean, you drive into Sandton, new building of Discovery, it's completely glass. Okay, new buildings, if you look at it, even if you go to Rosebank in Johannesburg, the Coca-Cola building made of glass. So many of the buildings are made from glass. Now, the problem with the glass, it creates multiple reflections. And thus raising the temperature. Okay, and last but not least, like I've mentioned to you before, extremely dark objects. Okay, these dark surfaces absorbs more heat, creating warmer conditions. Now, just to be more sustainable, what do people do? Now, very importantly, before I move on to my next question, we need to find solutions. How are we going to decrease this urban heat island effect? Okay, because we don't want these warmer conditions in our urban areas, right? It's not a question, but I want to discuss this with you. I mean, California, Los Angeles came up with solutions, for instance, painting their roads white. Because what does white do? It reflects it. Now, probably the most promising effect to reduce the urban heat island is afforestation, planting more trees, create open water surfaces. That's why it's so important to create these green belt areas. I'm going to use Johannesburg, for example, like Emmarentia, Parks, Zoo Lake. Okay, it has a cooling effect on these urban cities. Vitally important. Now, a different way, and the UK is doing extremely, United Kingdom is doing extremely well. They're using congestion. Okay, so congestion charge, for instance, they allow less cars to enter the CBD. Now, or rather, they need to pay. If you want to enter London CBD, you need to pay a penalty fee. Not a penalty fee, like a toll fee. Okay. And they try more for public transport. Cycling lanes. Okay. It's healthier for the people as well, better for your health, but public transport, definitely. Okay. Public transport reduces the amount of cars on our roads, which is definitely a plus point. If you just think of it, how many people can fit on a bus? If we look at the scenario between Johannesburg and Pretoria, we have so many different commuters. No, so many commuters between Joburg and Pretoria. Imagine if we can rely on public transport, how much less cars we will have on our highways. And with the less cars, there will be less carbon dioxide. Okay, so it means it will reduce the urban heat island effect. Now, please keep that in mind. How can we combat or fight against this urban heat island effect? Now, I've just mentioned it because it's negative, but keep this in mind as well. The positive of it, okay, urban heat island is always not, especially during winter, okay. With the urban heat island, it creates warmer conditions during winter. Okay, so it means our energy consumption, electricity consumption is less. I mean, to warm ourselves up with air cons, etc. Okay, but that's probably the only advantage we have of urban heat islands. But unfortunately, the pollution is a problem over there. Okay, so let's just quickly look at our next question before we quickly going to take a short break. But let's just quickly have a look at this question before we do our break. And our next question is, discuss the differences in relative humidity between the CBD and rural areas and the resultant precipitation. Now, I want to focus on a couple of things. Relative humidity. What does it mean? Okay. And resultant precipitation. Okay. Now, first of all, if we look at the resultant precipitation, we're talking about rain. Relative humidity is the water vapor content in the air. Okay. So what we want to discuss over here, basically, we want to see what's the difference in the water vapor comparison to the CBD, right, the urban area and the rural areas, and where does it rain more? Does it rain more in our urban areas or in our rural areas? Now, what is the relationship? What's the differences in between them? Now, first of all, if you can imagine, where will water vapor content be more? In rural areas or in urban areas? Now, I can give you a straight answer. First of all, think of vegetation. Now, if you think of urban areas, we just discussed it, artificial surfaces. There's less vegetation, there's less open water surfaces, there's more pollution, more combustion of motor vehicles. So it creates dry air. Where there's dry air, there's going to be less humidity. Am I correct? Okay. Vegetation, open water surfaces such as dams, less human activities is going to create what? More humidity. Am I correct by saying that? Okay. So let's quickly have a look at our answer. 2.4.4. Discuss the differences in relative humidity between the CBD and the rural areas. Now, first of all, we can mention 2.4.4, the relative humidity in cities will be lower. Than in the rural areas. And the reason for it, I've mentioned it to you, is because less vegetation, open water surfaces, so that means with less vegetation, with less open water surfaces, it's going to be limited evaporation. Now that coming back to my question. We need evaporation for the formation of precipitation. Precipitation is rain. Okay, if we don't have evaporation, we're not going to experience any rain. Okay, it's been a concern. So that's a major factor that plays a role over here. So let's just continue looking at what else can we add. We can also over there, drainage systems. Let's pay attention to that. The drainage systems in urban areas channels water away. And it reduces evaporation. Okay. Now, coming back to our figure, I want you to remember this. If you look at the CBD, let's assume it rains over there. What happens to that water? It creates immediately direct runoff. The water goes away. It disappears immediately. Okay. It goes into our drainage systems, it channels into there, it washes away. Okay. But when it rains in the rural areas, what happens? Okay. It gives time for infiltration. Okay. Now, let's assume it rains. Once again, I'm using the rugby field as an example, and I'm using the quad the concrete areas at your school, as an example. If it rains on the rugby field, what happens? Okay, the water infiltrates, and eventually, how will the water disappear? It will evaporate, okay? But when it rains onto the quad, what happens? The water disappears quickly because it channels into the drainage systems that the school, where the school infrastructure has been built for the school, okay? So no time for evaporation to take place once we look at artificial surfaces, especially in our urban areas. So we can add that. Not only is the vegetation, not only is the artificial infrastructure that creates less evaporation, okay? But, there's a big but, Great Halls. We do experience that it sometimes rain more in our CBDs, in our urban areas, than in rural areas. Why is that? I mean, we just looked at two major factors. There's less evaporation because of less vegetation. There's less evaporation because of water being channeled away, not giving time to evaporate. Now, what's the reason that we might experience more precipitation in urban areas than in rural areas? It's because of condensation nuclei, because of pollution. Okay, we experience more condensation nucleus in the urban areas than in rural areas. Why? Because of the warm conditions being created by pollution. Okay, so the chances for condensation, now what is condensation again? Think of it. Evaporation is when liquid turns into a gas. Okay, condensation is when that gas turns back into a liquid. Now the chances for condensation to take place is better in urban areas than in rural areas because of the amount of pollution created by us and activities in our urban areas. So we're going to write down the following. We're going to mention this. Okay, there's more condensation nuclei in CBDs, in the CBD, because of pollution. Okay, and the added moisture comes from the pollution. Comes from the combustion from cars and industrial activities. Okay, that's the reason we experience more mist, rain, or fog in the CBD. Okay.